Hi everyone, Mache here. I'm the CEO of Apis. I'm so happy to see that we have so many participants attending this webinar today. I think it's amazing that so many people found time to actually join this webinar. When we did this webinar previously in December, we had participants from around 50 countries around the world. I will guess it's something similar today. Before starting the webinar with Dean, some practicalities. Martin?
Yes, hello, my name is Martin and I will be the moderator for today's webinar. I'm also a teacher here at Apis actually, but for today I am the moderator. So I have briefly two important pieces of information for you. First of all, if you want to ask our main presenter here, Dean, questions, do that with the Q&A button at the lower part of your screen. That is questions and answers. If you have, all right, is there an audio problem with me? Just checking here. Got some information back in the chat here. No, we double checked and yes, good. We're getting some live feedback here from customers here, and right now we're checking the quality all the time here. So unfortunately, if you can't hear me, it's on your side. So here are my two pieces of information. If you want to ask Dean questions, do that with the questions and answers button at the lower part of your screen. There's a chat button as well. We prefer if you use the questions and answers button. And then I will aggregate those questions and put them to Dean towards the end of this talk in roughly an hour. So second piece of information, you may have noticed in our invitation email, there is a slight problem with the Zoom platform. There's a bug in the latest client which limits resolution, the video resolution on your end. So I will again send out in the chat, I did it just now, those two links with which you can install a version of the Windows and Mac client that should take away that problem. I think that's all. If you have any questions of a technical nature, you can put them to me while the talk is running as well, and I'll try to answer them as well as I can. And also don't remember, you can ask Dean questions about all the edgy techie thing that he's going to talk about. So do that during his talk, and I'll bring them up towards the end. All right, thanks for me. Back to you, Mache.
Great, thank you very much, Martin. And now the moment we all been waiting for, Dean Bubley.
Hi, Mike.
Good luck, Dean.
Thank you. So, hello, and good morning or good afternoon, depending on where you are. I'm Dean Bubley, and I'm the founder of Disruptive Analysis, is my research company. I am an industry analyst and also a futurist, and I cover a whole different set of areas within the telecoms industry and beyond. And so that covers network technology, policy, spectrum, core networks and other related areas, also communications applications and services like voice, video, unified comms for businesses. But one thing I do a bit differently is I look at all of these not just as trends in their own right, whether that's 5G or edge computing as today, but also through the lens of what's going to happen in the wider economy and technology world over the next 1, 3, 5, 10 years. So I do quite a lot of work on horizon scanning, looking at the implications of Internet of Things, or AI, or blockchain, or it could be new forms of transportation and vehicle and drones and so on, and how that interrelates with telecommunications, whether that's in terms of opportunities for service providers, or perhaps in terms of applications that arise from those which require connectivity and perhaps hosting, but also what it means operationally as well. So it's those sort of intersection points for me are some of the most interesting things that occur in technology, of where one or two domains interact and provide a real dynamic change to the historic marketplace. So today's webinar is about edge computing, and I'm going to cover a number of different things over the course of the next hour. If you've attended any recent events on edge computing, you'll know that there's quite often a lot of discussion about definitions, and I don't want to get too bogged down on that, but I think it is important because there are so many different approaches to defining edge, both in the telecoms industry and more broadly in the technology space, and I'll go through that. That tends to then link into who owns and offers edge capabilities, and I use the word capability because sometimes it's a service and sometimes it's a function or a property of another technology domain. A big emphasis is on 5G, but as I'll go through, edge is not all about 5G, despite often being put in the same sentence with it. It relates also to network function virtualization from a telecoms point of view, and clearly IoT in various guises as well, whether that's consumer, enterprise, and so on. And I'll be looking at this not so much from the technological implementation point of view, but more looking at the commercial opportunities, but also the difficulties and challenges and the strategic implications of all of this for particularly telecom companies, but also cloud and other players as well. So just before I drill into edge, I want to contextualize, and I use a version of this slide in almost every presentation I do, because what I see when I look across the whole of the networking and communications and internet space is two very distinct sets of trends which I can group together in terms of on this side you've got a set of forces around standardization, harmonization, the attempt to sort of create predictable networks and services which can be replicated, optimized, where there's a clear path to monetization by the providers and a certain amount of replicability. Which could mean that either one service provider is providing the same services as another, or that there's some mechanism for federation. And also this actually tends to make technology and communication services easier to regulate. But on this side, there's a number of other things which occur, which in a way democratize technology and communications, and it make it easier to either build networks, offer communication services. We've seen this over the last 10, 20 years with everything from voice over IP and messaging to Wi-Fi, where it becomes a lot easier for a company or even an individual to build its own capabilities without necessarily relying on the single standard or a service provider to deliver it for them. And that is also a set of trends we see continuing and that impacts today, whether that's the impact of open source, whether it's the ability to combine multiple different approaches to solving the same problem. It's open platforms, both in the network and in devices and IoT, which allow for configurability. And also sometimes there's price discrimination and arbitrage, which comes from the ability for customers to switch between either directly comparable or substituting technologies and services. And that impacts a whole set of service domains or user requirements, whether that's the connectivity itself, voice messaging I've referred to, but it could also be content, it can be enterprise vertical solutions, and today we're talking about cloud capabilities and the edge. So with that, I'm going to drill into the edge computing domain. And one of the things which I pick up a lot, which is not always apparent if you just look through the lens of telecommunications, is that there's probably four totally different philosophical views of what the edge is. And often each of these groups doesn't really understand the other three, sometimes isn't even aware of their existence. And whilst I think today we'll speak a lot about the multi-access edge computing as a standard MEC and 5G and the impact on cable and fixed line operators as well, it's worth recognizing that this term edge compute gets used, for example, in the data center world a lot, where I've been to a few recent events where people talk about edge markets. And an edge market is very different to an edge location. An edge market for a data center lens could well mean a second or third tier city, so not necessarily the sort of places you normally associate with big data centers like London or Singapore or New York or Frankfurt, but it could be somewhere as large as a Madrid or a Johannesburg or a US city, Milwaukee or somewhere. where they're not traditionally the hubs of compute and data center, but from that perspective, it is an edge location. It's outside of the normal major interconnection and hub locations. Then there's a different set of views again from the cloud and web and IT world. Some of these people have come from the background of perhaps doing content delivery networks and CDNs in the past, but also there's a requirement to push new forms of compute paradigms to the edge of the network or the edge of the compute domain. And that perhaps doesn't necessarily relate to the edge from an access point of view. For example, how many milliseconds you are from a mobile device to a cell tower, but it's perhaps more about the internal capabilities of a cloud service and how many points of presence it has. And actually, the latency I'll talk about in a minute, but it's the intra-cloud latency which is sometimes as important as the link between the end user and the nearest point. Then the last philosophy that really is important is the device mentality, the mentality of the people in the device world. I speak to a lot of companies that design chipsets or silicon designs, and one thing I see is a desire to put more intelligence, give or take the requirements for power consumption and obviously cost, but you see more and more intelligence going into devices. And so you may well find that a smartphone these days has a dedicated, not just an ordinary processor, but it might have an AI coprocessor or accelerator capability as well. In the industrial space, you're seeing a lot more intelligence on, it could be a robot, it could just be a sensor, it could be a gateway which links together a number of local functions, and then you have things like vehicles, where you have quite often a huge number of really powerful processors, particularly where you have prototypes for self-driving vehicles, which are really, to be honest, a supercomputer on wheels. And so there is this tension, four-way tension in terms of what is the edge. And everyone that I speak to believes that their view of the world is the most valid, and certainly I get that sense from the telecoms industry, which I'll talk about today, that the sort of the edge is the edge of the network. And that's, I would say, that's a valid view, but it's not necessarily the only one. And I think here is where we probably want to talk about why the edge is important. Who wants it, and what is it being used for, and what are the benefits? And certainly the primary objective of edge computing that I come across most often in the telecoms is around this concept of latency. How long does it take to send or receive data from a device, typically a mobile device, to the network and get a response from an application? The idea being that if you have both a fast radio network and you have the application logic essentially in the network, rather than on a distant data center somewhere else, then you can have, whether it's faster responses in a game or an enterprise application or a video use case. That certainly is one of the primary drivers for edge computing overall, but it's far from the only one. So if you speak to people in an IoT context, often they'll refer to sort of things like intermittent connections. Imagine you have sensors and a control unit on, let's say, a vehicle or a train, could be an aircraft even. You will not be in network coverage the whole time. And so even if you are using the cloud for delivering certain services of monitoring the performance of the vehicle, you're looking for potential problems or faults, or just the sort of ongoing requirements for passenger connectivity or anything else, you may not be able to rely on 100% ubiquitous connections. And so having some mechanism for doing at least some subset of that locally, and dealing with the intermittent connection and maybe sending data as batches afterwards when you reconnect is very useful. Then power management is an interesting one, because you do have this tension in the device world of requirements for longer battery life, which seems to mean that you want to have less processing done on the device and maybe offload it to somewhere in the network or the cloud. Again, potentially close, potentially far away, depending on what the task is. So that is definitely of interest, and sort of then there's this sort of complex set of trade-offs around what power do you need for the processing versus what power do you need for the connectivity. and certainly there is a desire to improve the power efficiency of the chips on devices so they can process stuff locally. It could be voice recognition on a phone, it could be sensors that have rudimentary machine learning capability built into the device, it could be a video camera where you have image recognition of a certain amount on the camera itself, so maybe it can recognize a crowd forming in a public space. But then you might want to have correlation. So if you're a security agency, you might want to have a feed from the 10 cameras that are looking at a square or a street, and if you see the same result from that cluster, then you maybe then escalate that to a human observer. And so there's different sets of requirements around edge computing, and it partly drives the architecture, but it's very much dependent on the application. A couple of others I'll very quickly mention. Data control and sovereignty. This is important in an enterprise context where either for regulatory reasons or just because of security restrictions, they're wary about using distant cloud facilities. And even if they like the idea of the cloud sort of APIs and compute capabilities, they'd rather have at least the most sensitive parts of the data residing locally on their edge. And the same thing applies sometimes. Governments are reluctant to have their citizens' data transferred outside of their borders. And the last one that I'll talk about here is the monetization. And the view is that, at least in theory, edge computing allows network providers that are investing in new 5G radio networks and core networks, or perhaps fiber and cable, to get a return on those investments by at least getting into, at some level, the cloud marketplace. A lot of the telecom service providers did try to get into the large-scale hosting and high-end cloud and hyperscale cloud business. Most of them now exited that because they didn't have a huge differentiation against some of the larger internet players. But perhaps with the localization and the asset base that telcos have, of whether it's cell towers or fixed line central offices and exchanges, perhaps they can get back into that game again. So just to give some examples of the huge variety of uses of this term edge computing, there's sort of three that really sort of stuck in my mind. The first one down here is the sort of the telecom view of edge compute. This is an architecture diagram from ETSI's, the standards body there, MEC, multi-access edge compute architecture linked to a 5G core network, which is all the boxes here. And certainly in a telecoms context, you will need to be putting certain functions of the network closer to the end user for a variety of reasons, either for internal operational reasons of next generation of networks where you can't be going back and forth to a central data center, or just because there may well be on customer premise sites or near to them for operational reasons, and things like mobility and handoffs as well. So the telecom view of edge tends to be very much geared around the nature of the network and what you want to do with it. But then this is an example here of an IoT edge compute platform, as it says on this diagram, which I'm holding in my hand in that picture, which I picked up at an embedded computing conference a few weeks ago. And that's designed as a programmable, essentially either a gateway or a controller for things like factory automation. It could be, or it could be in an elevator. It's embedded computing, which is the types of computing which would go into non-PC or phone environments. So it could be business, it could be some aspects of consumer services. But the whole point being that, in a way, it's there to stop the network being needed for certain use cases. It's able to process data locally and then just link to the cloud for particular purposes. And then the other example at the other end of the scale, I just picked one particular example, but there's plenty of others. This is a company talking about its edge data center in what it considers a tier 2 or tier 3 market, in this case, the US city of Atlanta. And so here you're going from also like milliwatts, or probably a watt or two power supply for this, to a megawatt or two for the data center over there. And the same term edge is used for both. And that leads to confusion, but it's important to recognize that there are different tasks you would use each of these different organizations and architectures for. So expanding this and making it more general, there will be a continuum of compute resource in future, whether that is for human devices, whether that's machine to machine, and a variety of other areas around IoT in the consumer space or industrial. You will find that devices have their own internal compute capabilities, particularly things like vehicles, which can have, because of a power supply, some really, really powerful computing capabilities. Individual sensors, and possibly even the accessories. So, if you look at the recent trend towards smart sort of ear pods or Bluetooth accessories to devices, they actually have their own processing in the accessory, which allows them to do quite a lot of clever stuff around, it could be voice recognition, or it could be healthcare applications and so on. So you have almost like accessories, devices, what I'll call the customer edge, which could be a home gateway, it could be an IoT gateway in a factory, and it could be perhaps something which is a personal compute hub of some sort, which perhaps might be a smartphone again. The network edge, and there's right at the edge, which is it could be the cell tower or street side cabinets for fixed networks, or even sort of Wi-Fi access points and controllers and small cells, which have perhaps some inbuilt compute or locally for something which controls a cluster of them. And then in most telecom networks, there's a set of different tiers of network aggregation points and hubs. Depending on the type of network, whether it's fixed, if it's mobile, the architecture, the transport connectivity available, there may well be 2, 3, 4 layers of aggregation and transport before you get to the core network within the operator. And each of these are possible locations, and I'll talk later about that, for edge compute from a network perspective. And then once you get beyond the telecoms domain into the sort of the internet, you've got various tiers of data centers, either which are oriented towards one particular cloud provider at the hyperscale far end, or ones which are maybe co-location centers and various internet exchange points as well. And they may well have third-party cloud companies which take space in those facilities. And what you'll get in future is this sort of continuum of compute, and depending on the application, depending on a particular workload for each application, there will be optimum places to point that, to locate that. And there's going to be a set of really, really complicated trade-offs involving latency, but also cost, ownership, price, security, power consumption, I'll talk about a little bit later, and also the availability of suitable computing resources, because it's not all going to be exactly the same sort of CPU cycle or gigabytes of storage. There will be different technologies underpinning this as well. And so terms that you often find when you talk about edge, bringing this into sort of the day-to-day conversation that you have in different parts of the industry. One thing that really does strike me is that we've had edge for a while, and so most ISPs have content delivery network or caching servers in their infrastructure, which have in some cases been there for a very long time from large internet companies, particularly streaming companies. In the past you've had as well a lot of dedicated CDN players. Akamai was one of the first, and there are others as well. And so in a way they are the sort of legacy edge which has existed for a while, and you're seeing these evolving further as well. So Google recently announced a cloud gaming service which uses its own servers that it already has in place, as well as looking at new infrastructure as well. And then one other thing I'm seeing a lot of is modular and micro data centers, DCs. And whilst there are very sort of physical form factors of this, a good way of thinking about it is a sort of a standard size shipping container full of servers. And you may well find that type of modular approach to building data centers crops up in industry. It could be at the base of a cell tower, it could be a metropolitan area, and you will obviously get different physical form factors, but that's a convenient way of thinking about it. And then a few of these others that I've mentioned already. A couple that I'll draw attention to. One is there is a sort of a sub theme within some aspects of edge compute around linking it to mesh networks, and also blockchain-based compute, where you perhaps have a distributed compute resource which looks like a distributed edge. And that's certainly something to keep an eye on. Like everything to do with blockchain, it goes through phases of hype and then disappointment, and we may well be due for another one, we'll see. but also the far point. There's a huge amount of investment that's going into new sorts of silicon over the last few years. And this sometimes, when we get sort of focused on the network, we think about. I've just lost the screen on this. Yeah, well, I'm not quite sure what's going on there, but when you think about thank you. The network, there's a lot of investment that's going into 5G, fiber build out, and it's very easy to think that that is the centerpiece of technological development at the moment. But actually, the last few years have seen a massive explosion in the semiconductor space as well, particularly driven by graphics processor units being of interest, and then more recently dedicated AI chips, which are appearing both on the data center side and in devices. And I think that it's interesting to see that a lot of those organizations are thinking about their role in the future edge. So I want to talk quickly about latency. Sorry, no pun intended. A lot of discussion around edge compute revolves around what latency is appropriate and whether edge compute is a way to reduce the time it takes to get response to an application. And yeah, that could be for an autonomous vehicle that requires information about the road conditions. It could be snappy response for gaming. There's a lot of use cases that people talk about. And another one is things like VR and AR headsets, where when you move your head, you need to have a very quick response, otherwise it can make you feel nauseous. And at the same time, you don't want to necessarily have all the compute in the headset because that then can injure your neck or something else as well. So there's also, again, all sorts of trade-offs. But ultimately, the latency issue comes down to the speed of light. And the speed of light is 300,000 kilometers a second in vacuum or air. It's a bit slower when going through glass. But what that means is that we often talk about milliseconds, and in 1 millisecond, light goes about 300 kilometers. Now, obviously, for certain applications, it's the round trip time, so you need to go to the server and then come back again. But that is an important metric, and so you find, for example, with voice and video communication, people try to sort of say that maybe 100, 200 milliseconds is about the limit before a conversation starts to feel awkward. Whereas for other things, you have much lower delay tolerance. Now, in the network and telecoms world, we tend to get very focused on this sort of 1 to 10 to 30 millisecond bracket. Certainly the recent announcement that Verizon's just launched 5G, they were talking about 30 milliseconds I saw yesterday. But then when you look at other industries like industrial markets, there are some problems that have a much higher tolerance, or rather lower tolerance, for latency. And so you start hearing people talk about microseconds. And that becomes important, for example, where you have, I don't know, maybe 2 industrial systems or robots that interact multiple times over the course of a minute or a day, and they need to remain in synchronization. And then even if you're starting to lose the sync at a microsecond or a few microseconds per interaction, there is a risk of collision or damage over an extended period of time. The same is also true in other things in say, vehicles. So braking. Arguably, you want to have the response time to recognition of a hazard and the car applying the brakes at the very low end of milliseconds or high end of microseconds. And certainly one of the things I often do when I'm at 5G related events is I ask the audience whether they would get in a vehicle with cloud braking. And usually the response is pretty negative. And I think that it's understanding these sort of orders of magnitude of latency is really important when we discuss the role and the applications and use cases of edge. There's certain IoT things which, frankly, seconds, minutes, even hours are fine. If you're an elevator technician, you don't really care to know, you don't need to know in real time whether the doors are sticking or are a bit slower this week or than it was last week, and you need to send an engineer out perhaps a month early. Frankly, a day of latency isn't a problem. So there's a lot of standards bodies and industry organisations involved in Edge. The one that is probably most relevant to the audience today is probably ETSI, that has been developing what was originally Mobile Edge Computing Standards, MEC, and then the name changed to Multi-Access Edge Compute, as a number of the Telecom members recognised that they actually want to be able to offer the same features on their mobile and their fixed line networks, especially where they have plans for sort of integrated and converged services. But then you have the Linux Foundation, which is doing a lot of work on a variety of edge-related standards, IEEE, IETF. The Kinetic Edge Alliance is a more commercial organisation, at the moment US-focused, which is looking at building an ecosystem of different layers of participants, from the software to the hardware and service providers. And then on the industrial and vertical side of it, there was a merger recently between the Industrial Internet Consortium and the Open Fog Alliance, which was more concerned with what types of compute resource you might need in manufacturing and process automation. So this is a partial list of use cases. Then I've borrowed this one. I've got others later on, but this one was quite telling because it comes from ETSI and what they have to say about what they see as possible use cases for MEC. And in a way, they list these use cases in one of their documents, partly as an example, but also so they've got the tools to think through what capabilities do we need, do we have the right specifications. But there's also a certain amount you can learn from this about what the industry expects to see or hopes to see from what the telecom-centric view of Edge is. There's probably three categories these can fall into. There's the internal requirements of the telecoms industry. So that's putting various of the internal network functions, whether that's virtualized VNFs, network functions, or components of Cloud RAN, or perhaps the billing and OSS out at the edge of the network, where it perhaps is more relevant in terms of both latency but also relating to the transportation, or it's doing an internal network function such as optimizing the backhaul usage in one form or another, or itself measuring and monitoring and reporting on realistic speeds and throughput. So that is, if you like, an application which is inherent to the edge. Then there are things where the industry is looking to provide sort of edge enablers to third parties and perhaps to their own services as well. So you could imagine that a sort of video production and delivery in a stadium, it could well be the gaming and low latency cloud. Now those are services that a lot of telcos want to offer themselves. They want to be offering streaming video, gaming, probably in conjunction with a partner, but it's essentially looking to help onboard and improve those services that they're delivering to customers. And then there's others which are more about integration into separate industries, providing capabilities via APIs to a general base of developers, which could be things like positioning. I've mentioned the factory automation use cases, or perhaps the ability to communicate between a vehicle and the local infrastructure. And by vehicle to infrastructure, it's things like roadside cabinets. In theory, could be compute resource to allow for traffic management or advanced warning of upcoming risks to vehicles. There's a number of telecom initiatives around Edge already. Most of these are still at quite early stages. I've picked out a few here. There are plenty of others as well. And it's worth looking into the stage they're at and also the partners they're working with. And some are sort of conventional, the sort of the ETSI type approach and that tie the edge compute into NFV in particular, and I'll highlight the Telstra Ericsson one here, for example. Then you have the Telefonica is working with a new emerging sort of standard open source approach called Cord, which is central office re-architected as a data center. And that is more looking at how to repurpose older phone exchanges in the fixed network, and which also perhaps are aggregation points for mobile, to use those as future data centers. And so that's a slightly different approach. It's more infrastructure led in my view. Then you have this company, Mobile EdgeX, is actually owned by Deutsche Telekom, although SK Telecom, the Korean operator, also has a stake. And that is looking at ways to enable developers to use telcos' edge resources. Yeah, they still haven't put out all the details, but that's quite an interesting one to watch, because they're certainly working and announced they're working with software developers such as one of the games companies, Niantic. Verizon has a number of initiatives in the US on edge compute, including a partnership it announced with NVIDIA, the GPU specialist provider. And then the other one I'll highlight for now is a company called Federated Wireless, which is working with a quite well-known edge compute startup called Vapor.io. Federated is interesting because it's not a traditional telco that's like a national operator. It's one that is working with the new shared spectrum band in the US called CBRS, which is going to allow for localized networks in certain areas, depending on where you are, and they will either be licensed and protected. There may be 4G, maybe 5G. And I think that's one of those interesting and new combinations where you have edge computing together with a new spectrum authorization model for connectivity, which perhaps allows the cloud industry to short circuit at a local level around the traditional telecoms stranglehold on usually an oligopoly of people who have the access network. So 5G and where it fits with edge. I'm not going to go through everything to do with 5G, but I just want to contextualize what I'm seeing, because edge fits into that, or certainly the 5G MEC part of edge fits into that. So where are we with 5G? Well, what's happening at the moment is some initial deployments of fixed wireless access, FWA. We've had announcements of the first 5G phones to expect sometime over the summer. And we are starting to build out what I'll call islands of 5G connectivity. It could be particular cities in the US or Europe. Obviously, China is looking at a whole range of deployment scenarios for 5G as well. You've got South Korea, Japan and other markets which are starting to deploy 5G of varying forms for different bands in different locations. But it's still very, very early stages this year. And from a MEC point of view, the focus is really still on pilots, it's on conceptualizing, it's on fundraising for some of the startups as well, and some early proofs of concept. Next year, we start to see 5G become much more of a viable proposition, particularly in the more aggressive markets like the US. There'll be more phones coming out, there'll be more fixed wireless access in more cities. We'll also have a lot more understanding of how well that works. At the moment, we're still very tentative around 5G, because we don't quite know how, for example, the millimeter wave spectrum bands will perform in the real world with real conditions, and when they start getting loaded up with more users. So the industry is really progressing fairly slowly on that. There'll still be quite limited coverage though. It'll be in certain countries and certain places, and everywhere else will fall back to 4G or whatever else is available. Also worth noting that 5G is not the only game in town. Wi-Fi is a new generation coming along as well. And from a MEC point of view, it's still fairly early in the cycle, and we'll see very, very early customer both trials and sort of early commercial pilots and demos, but it certainly won't be at the sort of mass market. All developers can sign up with a credit card. It'll still be a work in progress. Look out 2 years and things start to change a bit. First off, from the 5G point of view, there's going to be what's called URLLC, ultra reliable low latency communications, and that's the radio side of low latency. And to do that, you need quite a lot more control. You need optimal spectrum, in some cases particular regulatory permissions, and I think that's going to start being the point where we see 5G start to live up to some of its promises beyond more mobile broadband but faster, which is the main focus at the moment. One thing that is worth noting, and this relates both to 5G generally but also to edge computing, is indoor connectivity, especially at those high performances, is going to be problematic. Because the outdoor to indoor penetration, particularly for large buildings, will not be good enough to deliver full 5G without dedicated in-building systems. And while people are talking about those in-building systems, it will take a long time for them to be pushed out to all offices, all public buildings, all airports, all sports stadia, and so on. We'll start to see, partly because of that and partly because of the control, we'll start to see more private 5G emerging as well. And private 4G and 5G of particular interest in enterprise and industrial markets, and perhaps in some rural areas as well. And there's a lot of new business models emerging, such as neutral hosts, which I'll touch on a bit later on as well. And this is perhaps when the MEC market really starts to becoming more of a commercial proposition. We might see some federations of different edge facilities so developers can access them in multiple markets. I'll talk about federation again later on. But it should become easier for businesses and developers to actually access the edge capabilities if they want them. And then once you start getting to 2022, I'll be honest, even though I forecast various aspects of the market, there's so many variables between now and then that you can read the scenarios from a whole different set of angles. What I would expect to see is, firstly, 5G is going to be fairly mainstream by then. In most developed markets, most new phones, most new contracts will be 5G based. We'll start seeing it more in the sort of mid-tier markets as well. I'd expect China to be quite advanced on 5G by then. And so pretty much everything else that comes with it, whether that's edge, or what we're talking about, network slicing, which is the ability to virtualize networks with different capabilities for different audiences, those will start to form into more integrated propositions. And whether that's the telecom operators themselves offering sort of vertical solutions for particular industries or particular use cases, like, I don't know, maybe for AR and VR. It's a little difficult to tell, but we'll start to see these integrated bundles of connectivity, slicing for control, and edge compute for processing. We can debate whether or not that's going to be the fully standardized MEC model and the telecom sort of standardized view of the world, or whether perhaps it's more of a cloud or IoT-centric approach. But I think that we'll probably see combinations and hybrids of all of those. One other thing that's worth saying is that although people talk about AI and AR and VR as 5G technology or 5G use cases, the truth is that they correlate with 5G, they're not caused by it. All of these things exist and will exist anyway, irrespective of 5G. Most AR today uses Wi-Fi, on particularly the headsets. Almost all of them are connected either via a wired tether or Wi-Fi. But what you will see is, along with the development of 5G, some specialized versions, but also each of these technologies will evolve faster and faster themselves. Major use case for edge compute is varying forms of cloud and everything as a service software, whether that's from a desktop or from a PC, or from a tablet or a phone. That will be a big driver of the requirement for low latency. It could be everything from unified communications and collaboration in enterprise to sort of voice, video. It could well be for industry-specific tasks around, it could be oil, it could be health, it could be finance. That will be quite demanding for, as it is today, cloud capacity, and there will be certain workloads which are more latency sensitive than others. Automation and robotics, clearly important. Arguable whether that is a domain for the telecoms industry, particularly inside buildings. I know a number that are looking at that, but what I'm expecting is that in most large telecom operators will pick 1, 2, 3, 4, 5 verticals to really focus on. And it'll depend on where they are in the world and their existing customer base. It could be warehousing and logistics, it could be healthcare, it could be mining, it could be finance, it could be smart cities, it could be smart electricity and utility grids. And I think that each operator will look at creating solutions for their chosen markets, and then they will have another tier of sort of horizontal services for everyone else. And so we'll see some that focus on the industrial and robotic space, but not all of them. Machine vision and AI. I referenced that earlier with the video analytics in cameras, and I think that that's going to become a really important part. And here, the demand is not so much for low latency, although that's important in some cases, but it's because you don't want to ship 4K or 8K video from 1,000 or 1 million cameras all the way to some remote data center, because you'll need terabits of capacity to do that. what you'll probably have is various tiers of compute. So the camera itself will probably be able to do limited recognition. Ultimately, if you're a security camera, 23.5 hours out of 24, you're staring at a blank wall. It's only when something happens you actually need to send the data anywhere else. And so you'll find a certain amount of filtering done on the device, a certain amount of the gateway. Then perhaps when you want to correlate 10 or 100 cameras, then it may make sense to do it at the edge of the network. And that will link into various other use cases of artificial intelligence as well. Life-critical systems, obviously very often very latency sensitive. However, there's an arguable question as to who wants to bear the liability and insurance risk, particularly for things like medical devices or public safety, and whether that's a service provider or whether it's a medical equipment specialist. One thing we're going to see more of is devices that connect to multiple networks, either at the same time or are easy to switch between them. We see this with some of the early eSIM-enabled phones and certainly vehicles as well, where they have ability to connect to multiple different networks. There it's going to be interesting to see where the edge makes sense to go on that, and I'll talk about that more in a few minutes. And then the other thing to think about again is the network coverage. So a couple of dimensions. I look at, for edge applications, there's no one way of classifying them, but one that I'm finding useful is this 2x2 matrix, where is the application accessing over one well-known network or multiple or every network? And then the other thing is it connecting to one, is the application resident in one place, or is it a multi-local application? So for example, where you have the telco's own infrastructure, it's NFV or billing or cloud RAN systems, clearly it's focused on its own access network. Also, they may well find that a network that partners with a gaming company dedicates that for, if it's a large operator, to its client base, its broadband subscribers. You might find telcos partnering with a smart city or metropolitan authority where, again, they're providing the connectivity layer. It's well described and it's well known whose network it is. But there's other applications, which is like more the long tail applications, where if you're a game developer, you want your game to work on every device, on every network, on Wi-Fi when someone's at home, maybe Wi-Fi in the office as well, who knows. But then what that means is you cannot know whose edge is closest, and you need to work with some way of getting access to all the relevant edges, because you don't want to have to hire a legal department of 100 people to cut deals with 800 telcos around the world. The same thing with autonomous vehicles, a lot of voice assistants for AI, things like Amazon Alexa, they will be connected via every ISP, and they don't want to have to do deals with all of them. The other dimension, multiple cloud, this is where certain applications can reside in entirety, or workloads can reside in entirety in one network. But also you have applications where you have different components. So it could be video where you've got the advertising coming from a different server, the analytics and AI being done, maybe the subscriber login is from a third. You've got all these different components for the application. And so you need to be able to get to those which won't be done at the edge. So you might have the core logic at the edge, but then there's going to be microservices and functions and API calls everywhere else. And so the question then is it enough just to have one chunk of the application residing in the edge, or is it more the coordination you need to think about? And then lastly is there's some very complicated use cases which not only have multiple network access requirements, but they also have requirements to get and access information on a multi-cloud basis as well. And I'm struggling to see that the telecoms and MEC view of the world really fit nicely in with that. One thing I'll note is that 5G is only a subset of this, and there's a line which I agree with that I've heard from a few sources recently, which is 5G needs edge more than the edge needs 5G. There's a lot more to edge than just the 5G and mobility aspects. It's important, but it should be borne in mind that has to be seen in context. And there's a bunch of other dimensions I don't have a chance to talk about now. Mobility is one. Is there a requirement to hand off from edge node to edge node to edge node? What type of compute resource is needed? Is it just standard CPUs? Is it GPUs? Is it AI chips? Is it storage? Not every edge location will have all of those resources, and you may find that certain applications are developed for certain types of chipset. And so that brings me on to some of the complexities that people need to think about. there will be challenges, and so some of the ones that I'm seeing at the moment is around this issue of mobility, particularly for vehicles where you're going from one mech zone to the next. How do you transfer information and state that it's my car, this is the mileage, this is the, I don't know, the toll fee information, or the capabilities in terms of braking and engine. You know, there will need to be some level of continuity of the data. And the sort of the extension beyond point to point is the roaming. Will your edge roam with you when you go to another country or another network? In fact, what happens generally when the device hands off from one network to another, 5G back to 4G, or to either a carrier Wi-Fi or private Wi-Fi? Where does the edge go? If you're using an application on your phone, your game or your enterprise application, and you cross that boundary, where does the edge compute shift to, or do you end up going back to the telco edge that you were using before? Indoors is interesting. I have heard almost no one talk about edge plus MVNOs. And I think that that's something that is going to be of real importance to a lot of service providers, particularly in IoT, because a lot of IoT networks and connectivity is done via an MVNO model. What's the developer APIs, either on the cloud platform itself or even on the API in the device OS? Unknown. VPNs. So I realized that my phone, the VPN client, is still, I'm doing this in Stockholm, but my VPN exit point is still in London when I flew in yesterday, which means that if I had an application on my device that's looking for an edge, and let's say it's based on a GPS location, and so there's a local Stockholm data center, my IP traffic would go all the way to London and then come back again. And so it added in 2 sets of long round trips, which would probably make it even worse than just using the London data center to begin with. And that's really hard for the network to have much control over. Other questions around billing and charging. If you have edge compute resource, how do you determine whether a given application or a given user is allowed to access it? Do you need to actually put some of the charging and billing capability at the edge as well? Because there's no point your application going to the MEC server, which then has to speak to the billing system 1,000 kilometers away before it can actually access it. So there's going to be a whole set of quite interesting challenges, and it's going to vary depending on the use case, but it shouldn't be underestimating any of these potential gotchas as either a delay factor or perhaps more likely pushing the short-term and medium-term use cases towards certain examples that work around this. And yeah, another good example is in enterprise, which is where you link the edge perhaps to the connectivity. And you might think, well, okay, you have a wind farm on a hilltop, but then who's doing the network? If it's both wireless and wired, you probably have wired connections because you probably laid them along with the power cable from the generators. But if you're flying a drone to do inspections of the blades, do you have 4G or 5G network? Is it the national operators? Does the power company put their own wireless coverage in? Do you try to use some sort of one on unlicensed spectrum as the controller? Maybe. But then if you want to use local compute to do the image recognition relating to the camera on the drone, is it done on the drone? Is it done in your vehicle if you're the engineer? Who knows? Is there some sort of way that you can offload the image processing to a local server if you're a maintenance contractor? I don't know. We're going to have to sort of come through a lot of cycles before some of these scenarios actually work. When you consider the number of stakeholders involved here, where you've got the national network, you've got a local network, you've got the infrastructure owner, you've perhaps got a company which builds the turbines, a separate one that builds the blades, contract maintenance. And you can replicate that for 101 other industries as well. It's going to be complicated, and who gets access to the compute resource or the communications network is a tricky one. And this is something that another chart I present a lot is this. Well, I apologise for it because it looks complex, but it's actually not complex enough. I can only fit six dimensions onto a 2-dimensional page. And the future networks are going to be used for so many different things in different ways. And whether you're talking about network range or speed, but also you've got importance. How important is a given application or a network? Is the coverage good enough, or does it need to be absolutely everywhere? So even 3D, again, for drones and large structures. Is it provided as a network by a service provider? Is it private? Is it this sort of wholesale neutral host model, or some other form of new decentralized community-based approach to networking? You've got these sort of other 10 or so dimensions you could build. And as well as connectivity, there are going to be computational requirements that associated with these as well. And so what you will get is a situation where service providers will do some where they can, but there's going to be a lot of slices of this where it will make sense for a third party to be involved both on the connectivity layer and on the edge compute. This is edge compute fits into a really interesting and complex situation which we're seeing with networking generally in enterprise and IoT. Leave edge computing aside for a second. What you're seeing is a number of industries where there is both the traditional sort of telco, which, as I say, is going to be doing a number of verticals, but other industries they want to have their own private network, say manufacturing. There's this sort of a wholesale model, maybe for property development or hotels or airports, where there's a network which is owned by the venue, where the national operators either roam onto it or have some sort of reverse MVNO deal. I know there's a number of companies that are looking to build out their own MVNOs, perhaps could be a government department. And then there's this sort of world of network slicing where either the mobile operator or 5G operator runs a slice on behalf of a company or allows them to manage it themselves, perhaps with a private core network. And against all of this, you then have the compute layer as well as connectivity, trying to fit on top of all of this. And I think that there's going to be so many permutations. We've come back in 3 or 4 years' time, it'll all probably look a lot clearer, but there's going to be a lot of experimentation, I think, in the short term. And it's not just that. Yeah, so I mentioned that sort of you've got the connectivity, you've also got everything from SIM management to numbering. What do you do about voice communications? It's not as though it's just the radio and the edge compute. There's all of these moving parts that needs to be thought about for each of those verticals and scenarios. And so I think this is going to be a little bit of a break. We'll see pockets of development here and there, but don't underestimate the complexities involved in building future enterprise network and compute resources. So a quick word on power. One of the challenges for the industry, for the whole computing industry, is getting power, managing battery life on unconnected devices, getting cooling and clean energy for the largest data centers. Ultimately, all computing, whether that's storage or processing, is about energy. It comes down to pretty much if you have a physics background, entropy. And we're messing around with information and bits. And although you can't really compare a CPU with a GPU, with storage, with network transfer and distribution, it's probably the only metric where you can try to compare everything. And so you have this huge continuum in compute of down to sort of milliwatts at a chip or sensor level to megawatts, even gigawatts for the largest data centers. The cellular industry and the telecoms industry typically lives in this sort of middle range here, where you've got a normal cell tower is a 1 or 2 kilowatt power supply. You might find that a central office or an exchange point might have 10 or 20 kilowatts, and you could perhaps fit a number of server racks in there. All of these you could put additional power supplies in. But that ultimately puts an envelope on the amount of compute you could do, and the number of locations you multiply by the number of locations, you basically look at the overall aggregate share of compute that could be done. Also need to bear in mind that most telecom companies themselves have their own requirements and goals around energy consumption, CO2 equivalent emissions, which perhaps is a constraint on the sort of ultimate ambition around compute. It's also worth talking about the ecosystem here. It's not just the network companies that have local points of presence. Property companies have, retailers have, all have large amounts of footprint where in theory they could put compute capabilities and have connectivity. So a couple of years ago there was this interesting acquisition which Amazon bought Whole Foods. And I speculated at the time, and I have a feeling I might be right, that it's not all just about groceries and frozen food. I think actually what Amazon bought was a network of locations which could potentially become data centers as well, or locations for mini data centers. Supermarkets have a very, very high energy density because of all the refrigeration. And so you can imagine that if you have a city centre location, you've got the AI smarts to improve inventory management, maybe you can convert part of the old cold storage room into a future data centre if the local regulator allows you to. I don't know, hypothetical, but it's wrong to think of the telecoms industry as the only organisation that has localised physical assets with connectivity and fibre. So, wrapping up in the final phase of this, I see three evolutionary paths for edge computing overall. Leave aside the sort of device edge and gateways, but the sort of the cloud meets the edge. The vision which the telecoms industry mostly focuses on is what I'll call the single network MEC approach, where you integrate the edge compute with the NFV, network function virtualization, and you put compute resource, it could be at cell sites or aggregation layers or fixed central offices, and you look for particular use cases which can be delivered by a single service provider. And I think that some of those will be internal to the telco, but then the question is, what beyond that? Are you going to find individual operators working with games companies or enterprise software developers? Maybe, if the operator is really focused on that and has a large enough audience. But I think the other interesting ones are either what I call the interconnected edge, which is where you have more of a focus on connectivity, not to the end user, so the mobile device to the radio to the edge side, but from a localized edge, which is, if you like, edgy or close enough in a small city or wherever, but it has multiple fiber connections, it has good connectivity to all of the multiple clouds that it needs to Amazon and to Google and to Azure and all the smaller niche players as well. It's also got good long-haul connectivity, internet exchange point connectivity. So I think that what I call the interconnected edge is going to be really important as well. Maybe not quite as localized as the single network telco ones, but nonetheless close enough for latency to improve. And what I'm starting to see emerge now is the federated edge or open edge, where you have perhaps aggregation platforms which bring together multiple different edge resources. Could be multiple telcos, it could be multiple data center owners, and present a single view to the developers of the entirety of the sort of edge portfolio that they've built. And I think that potentially ends up being the sort of winning approach here, where if you're a software developer or an IoT developer, you sort of don't care which are the underlying data center and telco networks that are physically locating or virtually locating those edge resources. You want to be able to consume them from a developer point of view in a similar way the way you do for hyperscale cloud today, where in the final analysis, it may well be signing up with a credit card on a web portal. And I think we'll see sort of various sort of subdivisions of all of these. I don't have time to go through them now, but I think that there's some interesting stuff that's going on with Cloud RAN and certainly private edge. Is private edge just computer room 2.0? Maybe. But I think that there's a lot of interest, say, from Amazon, which is running its thing called Outposts, which allows enterprises to have a hybrid cloud of hyperscale plus certain amount of on-premise, perhaps for sensitive data as well. So, looking forward, one of the metaphors I use, if I look out a few years' time, is the world's compute looks a bit like a dumbbell. And I think that what we'll see, if we look back in the lens of 4 or 5 years' time, that where are the processors? And I think that, as with today, a large chunk of the overall heavy lifting compute will be in big data centers with big power supplies, huge football field size locations. There might be like 150 gigawatts of compute in those type of things. And then a lot of the rest of the compute is actually going to be in phones, in PCs, in cars, in edge gateways. And then you get what's left in the network and the sort of the network edge. And I think that numerically it's going to be quite small. It is the sort of interconnection bit of the dumbbell. Potentially it's more valuable on a per cycle per watt, if you like, basis, per rack, per server, per compute workload quantum. But for me, it's not going to be the factor which changes the overall dynamic of the compute marketplace. I think it's going to be important for certain things, but not others. And the question is, how do you present the value of this to developers so they put the right workloads in the right places? And I think that a lot of this is going to come down to the telecoms industry not getting distracted by unrealistic, what I call unicorn visions. I think there's certain things where there's a clear requirement where edge definitely adds to both the infrastructure and the capability of delivering stuff. And I think the first and foremost is internal use cases within the telecoms infrastructure itself, whether it's optimization, whether it's for putting virtual customer premise VNFs or virtual EPC or border controllers or security gateways, CDN nodes. There's an awful lot of sort of network components that themselves make sense to put at the edge. I think that security in particular is one to keep an eye on here. I think the next category is essentially looking at wholesale models relating to edge, and I think we're going to see this operate both ways. I think that the operators are going to put their compute in other companies' local data centers, and then you'll find some cloud companies buy wholesale from the telecoms MEC community as well. And so I think that whilst there's always this tension about working with a Google or an Amazon or a Microsoft or a Alibaba, I think that wholesaling localized compute resource to the hyperscalers is going to be an important role for telcos in the future. And then there's likely to be this federation and aggregation play as well. It's still early days, but there's a few early organizations looking at that. And then I think the other category is what I'll call artisanal systems integration. And this is where a telco, and this is going to, there's no pattern here. It's going to be individual operators working with individual customers based on individual regulations and what they see as dynamics. And it could be that they get involved in a smart city project. It could be they're working with local security authorities. It could be that there's a local port or airport or manufacturing plant where they custom create perhaps their own an individualized network slice on top of 5G, where they perhaps work with local IT partners as well as the enterprise. And I think that there will be a variety of use cases like the ones we discussed earlier, but they're not going to be sort of templatable and very easily repeatable. So the issue here is going to be monetizing that where you're getting money from a systems integration or an outsourcing contract. Then the ones which are more difficult, the long tail, sign up the credit card, I think that's going to be many years away. I think the in-factory side of things is going to be problematic for most telcos unless they really go deeply on the industrial expertise. The roadside functions, I think we'll see a lot of interesting demos, pilots, government-sponsored projects about smart highways. I have my doubts as to whether we're going to see autonomous vehicles communicating with each other or vehicle to infrastructure going down the highway anytime soon in commercial reality. And I think that that's partly down to the limits around the network and edge compute, but frankly there's a bunch of other issues that connected vehicles and particularly autonomous vehicles have from a regulatory point of view as well. AR and VR, I know a lot in the industry seem to think that you'll be able to deliver edge-hosted AR and VR rendering. I haven't yet seen anything which lives up to that hype. I could be proved wrong. Maybe it's something like gaming where it makes sense. But firstly, I think that the onboard capability in the device is quite high. But also where you have communications, it's the long haul bit that's the limiting factor, not the device to network. It's the network, intra-network, that's going to be more important. General enterprise compute is probably the sort of most interesting one from a cloud point of view, but it's also the one where the existing cloud players will play to their existing strengths. Utilities and smart grid, that's not going to happen too quickly. Utilities are notoriously conservative and they also like to own stuff. So I think that firstly it's going to take a while, and secondly I think it's mostly going to be done in-house when it is. Life critical, again, part of the issue there is going to be around coverage, network coverage. Most hospital operating theatres are indoors, last time I checked. and also around the insurance and liability, which there's very few in the mobile industry in particular that are happy to give SLAs, let alone SLAs with a safety-related aspect to them. And a couple of others. I mean, I haven't mentioned Wi-Fi, but an awful lot of edge resource is going to be accessed over Wi-Fi from inside a home or inside an office. And there it's really unclear to me who the edge provider is, but it's probably not the broadband company. So how many edge compute facilities and where are they going to go? Obviously, it depends on the size of the country and a particular operator's infrastructure. There are some people who believe that there's going to be edge compute at every cell tower or every street side cabinet. I am unconvinced. I think there's going to be a huge set of problems just coming up with the business models and the investment case for that, as well as things like power consumption being a challenge. I think more interesting is the metro hub and aggregation sites and sort of regional data centers. There's certainly a few service providers I've spoken to recently who are saying that for a medium-sized country, they can probably do quite a lot if they have 10 edge locations. Because it's low enough latency, it's a couple of 100 kilometers. It means the actual sort of light transmission is a millisecond or two, which if you think about the overall delay budget for VR communications or gaming, when you take into account the device at one end, the server delay, all the internal processing, it's low enough to sort of take that out of the equation. And then there's some say island countries or smaller nations where frankly just having one or two of their own decent sized data centers is edgy enough. If you're a Pacific island, you don't want to necessarily haul half of your data and processing capability from across the ocean, and so just having something in market will make a significant difference in the near term. So very last slide, and then I'll open to questions. Recommendations, and particularly for telecom operators and vendors. First thing is, edge computing comes in many styles and scales as well, milliwatt to megawatt. It's not just all about mobile edge computing, it's not just all about multi-access edge computing. CDNs and caches are existing almost like legacy edge, if you think. So we've been doing this for quite a while. And I think that relates to how I see telcos, or how I advise them in terms of looking at the edge. I think that MEC is going to be important, but it's still extremely early days, and it's not the only game in town. So I would warrant caution on the sort of the putting the MEC aspect at the core of overall edge and cloud strategy. And I would say that it actually makes sense to decentralize the strategy itself. And so there should be enterprise groups, there should be consumer groups and TV groups and developer-facing groups that have their own attitude and views of edge. It shouldn't just be tied into the 5G deployment. That's going to happen too slowly. And it shouldn't be happening just by the NFV team either. It should be looked at by people who deal with developers on a day-to-day basis. And it's this attitude of thinking about these three things from the customer perspective, not the technology and the standards basis. It's what do consumers actually want? What do developers want? And this is really important because developers don't want to have large legal teams to negotiate hundreds of different edge contracts. They also don't want to get locked into particular platforms necessarily. And they also need to have the ability to trial things, to scale up easily, to have sort of sandboxes to test things in, to make sure that they're able to see a roadmap and to have support infrastructure rather than just the technology. And I think that if you look at most of the telco API initiatives over the last few years, it's that sort of wrapper for developers that's often been lacking rather than the underlying technology. There are cost-saving aspects to this, both particularly for the internal use cases at operators, and really this ties in with the idea that operators in general should be, if you like, eating their own dog food and demonstrating their own use cases for a lot of their technology, and edge being one of them. I think that partnering is going to be core here. And there's lots of different vectors for partnering around edge compute. Obviously with the large cloud players, but also asking the IoT and industrial and IT players, what do they actually want and need, and what do they have already? And what are the technology standards they're working with, open source and so on. And last point, start soon. This stuff is happening already. It can't afford to wait for ubiquitous 5G. It can't afford to wait for ubiquitous NFV either. There are IT and IoT use cases that are happening now that need to have at least some measure of edginess. Thank you. So I don't know if we have any questions, Martin?
Yes. All right. So we have not so much of a question than a remark or a comment that I can give you.
Okay.
I think people have been riveted to your presentation, so there are not so many questions. You can ask questions now. You still have a few moments to do that. Use the Q&A button at the lower part of your screen to throw some questions in here at the end of all things. I have a comment, Dean, from Patrick. Patrick on Verizon, I believe. I believe Patrick is on Verizon in Brussels even. He says that Verizon launched 5G phones yesterday.
Mm-hmm.
Yes.
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 Yeah, and absolutely. And yeah, there's been this sort of race around 5G. So Verizon's been doing fixed wireless access for a couple of months. Obviously, in Mobile World Congress and around that, there were announcements of early 5G phones. Everyone's been rushing, and it's been a bit of. I hate this 5G race thing. It's nonsense. But everyone seems to be seeking the first press release. Oh, we were the first this, first that. We got the first 5G phone in blue or whatever. So yeah, there was certainly an announcement for Verizon this week, and also the Korean operators have announced their pricing as well.
Yeah. It also kind of depends on what you call a 5G phone. I saw a 5G phone a long time ago, and it was an entire rack of things.
Yeah, and then there's this whole question around fake 5G.
Yeah.
There's a lot of controversy, and I'll admit to fanning the flames myself about whether what AT&T calls 5G evolution is basically 4G with a sticker on the top. And I think there's a lot of the narrowband IoT stuff, which launched about 3 years ago as part of LTE. Miraculously, that's now been called 5G, which is odd because that seems to suggest Deutsche Telekom missed out on putting a press release out with the first 5G network 2.5 years ago. But whatever.
Whatever. We have a question here from Mohammed saying, will this webinar be uploaded on your YouTube channel? The answer is yes.
Good.
And also, let's see here, how will the mobility happen, for example, in connected cars?
Well, that's a very good question, and there are various people who are looking at in the standards and as an overlay of transferring data. Well, because there's multiple different things. There's mobility of the state of the user from one edge node to the next, but there's also you need to transfer the application as well, because not every edge node is going to be large enough to have all the applications that ever might want to use it locally. So it may well be that they have to go and fetch certain software components to have the application resident as well as the user data relating to mobility. I suspect there's going to have to be an AI layer which actually can work out the fact that you're driving down this highway at this speed. You can almost like preemptively expect that you will need to move to the next compute zone. That's going to get very difficult in, for example, urban areas, or if you have a underground parking garage. I think there's going to be certain instances where it's going to be well described, and where you'll have the application manufacturer or the car manufacturer working with the network. But I do see that as a challenge of, for example, if you're walking down the street with a game or a navigation app, what's the handover process? Is there latency associated with the handover? Yeah, and how much of it is going to be driven by the radio conditions? So, sometimes you'll find with 5G that you may actually fall back to 4G if it's got better connectivity. But will that then impact where the edge is? Don't know. I think there's going to be an awful lot of I suppose corners are where all the edges come together. So, I think I used the term corner computing recently, but I think that's going to be a topic of our webinar in a couple of years' time.
All right. So that's going to be the sticker that you stick on everything. That's a new thing, the height for corner computing. Can I just finally ask if everybody, if you have any final questions, just throw them in. I just noticed, Dean, there that under your company name it says "Don't assume."
Yes.
I think it reflects your disruptive nature there. Can I just ask you, what's the most common erroneous assumption? What do people get wrong about edge computing?
I think it goes back to my initial point with the sort of 4 different philosophies, and I think that everyone gets fixated on their and their suppliers and their competitors' view of edge without realizing that these are other worlds as well. And I think they do intersect and in some ways substitute. And I think that, for example, I hear a lot of people say, oh, well, one of the big use cases for the network edge is to offload compute from devices. But actually then you talk to the device companies and say, no, we're getting better silicon. We want to do more compute locally because of privacy, for example, or we want to do machine learning right on our edge where we can control it. So I think that there is going to be the sort of tension between the network, the device, and the hyperscale cloud, and also what it is that developers want. And I think that a good example of that is going to be the sort of things like image processing. Are developers going to want to use a cloud-based resource for that? Will they want to program it locally? Will they want to sort of pay for extra bandwidth to get somewhere? Or will they think, well, actually, the edge compute I can do is use the local camera to work out which bits of the display my eyes are looking at and focus the bandwidth and pixels in that part of the image. And frankly, the rest of it can be low res and no one's going to notice. And so you may end up with multiple ways of solving the same problem. You don't need to ship, for sort of video cameras, you don't need to ship 8K video for the 23.5 hours a day when nothing interesting is happening. And so I think that people sometimes, they'll assume that we need a certain amount of capacity and a certain amount of cloud capability. There's going to be lots of ways of sort of filtering and optimizing that, particularly if cloud and edge compute and network resource is expensive. People will look for ways to optimize their own expenditure for the same outcome.
Right, thanks. Excellent answer. Let's just say we do live in interesting times.
Oh, very much so,
It's not boring anyway.
It's keeping me very busy at the moment.
All right, so thank you very much for those answers, Dean, and thank you very much for the superb presentation. So, Mache, if you want to return to the stage and say goodbye. Stage is yours.
Thank you.
Thank you. Well done, Dean.
Thank you.
Well done.
You enjoyed it.
Guys, I hope you enjoyed this webinar as much as I did. Thanks for a great presentation.
Thank you.
Dean.
Thanks for the opportunity. Really been interesting, and love your setup here as well.
Great. Thank you very much. Very appreciate it. In the coming time, we're going to have more webinars like this. We're going to bring more talented and knowledge people as a guest speaker to our webinars. We're also going to have more webinars with our own trainers, and a lot of new stuff will be mentioned here for sure. To make sure that you don't miss anything, follow us on our social media, sign up, subscribe to our newsletters, visit our website. We're going to have all this information there. And yes, we had a question about it, but once again, this webinar will be recorded, will be available on our YouTube channel. So you're going to have the possibility to see it again. If someone missed it or want to recommend someone, that can be just fine. Until then, have a great day. Thank you.
Thank you.
Bye.